Let's take a look at the last piece of logic using Euler diagrams to verify syllogisms. A syllogism is just a list of statements, declarative statements, called premises that follow a conclusion. So I have a premise, then a conclusion. It's going to be valid when the premises are all true and then the conclusion is true. The conclusion can be false, though, even if all the premises are true, and that is an invalid syllogism. What does this look like? In Euler diagrams, they look similar to set diagrams, but you'll notice they have circles inside of other circles, instead of circles overlapping. So if I say all people are mortal and Socrates is a person, therefore Socrates is moral. And so I'm using that statement to evaluate the syllogism. So let's use another example of an Euler diagram to determine whether something is valid. All poets are good spellers. So poets are the outside circle, good spellers are the inside circle. Dante is not a good speller. So Dante isn't in that inner circle of speller, but therefore he's not a poet. Are we really sure that's the case? So if I would look at the diagrams where I say all poets are good spellers, that would be the outer circle spellers, inner circle poets. And so Dante is not a good speller, so he does have to exist outside of both of those circles, which means he cannot be a poet, and this is actually valid. So all this has to do with is setting up the circles within each other so that we can find where people fall. All tigers are meat eaters, and Simba is a meat eater. So we have meat eaters, then tigers. Therefore, Simba is a tiger. Is it possible, then, for Simba to not be a tiger, but also be a meat eater? And the answer is yes. Therefore, it's invalid. So I can't use the inner circle criteria to justify what my object is. If he was not a meat eater, he would definitely not be a tiger. But I can't use that inner circle piece to make the distinction. There are some ways around this with saying some, and that can be misleading in a syllogism because all of these things could represent some. So there is a lot of confusing pieces. So in this piece, is this syllogism valid? All car manufacturers after 2007 have side airbags. Some cars with driver's side airbags have passenger side airbags. Let's see what this looks like in the diagram. In every possible way that I draw this diagram with some, it looks to be invalid. And our strategy is going to find a diagram. And after looking at several versions of this, it seems impossible to actually get to an invalid place where it's not true. If that happens, then we're going to say, hey, this is true. So think about playing devil's advocate here. Just by pure luck, that first diagram shows that it is possible that no cars manufactured after 2007 have passenger side airbags. So therefore, I can say it's invalid. In problem-solving strategies, counterexamples are very productive. A counterexample can be one of the quickest ways to determine if something is valid or invalid. Another would be extra conditions that are present in Euler diagrams. So notice I have a circle inside of a circle, so there's always two conditions that are having to be met. Each diagram in the figure illustrates the following premises. All A's are B's and some B's are C's if I look at these diagrams. And so if I think about this, then there's a whole lot of possible conditions. And so let's associate each of those pictures with a statement or phrase.